Hello, still with me, Firda Basbet, in Basic PLS SEM using Smart PLS 3. Having learned how to create and estimate a PLS path model, we now focus on understanding how to assess the quality of the result. So we are in the session 3, evaluation of the measurement models. As we are aware, the path model consists of two inner models and outer model. Inner models also called the structural model, and the outer model is called the measurement model. Model estimation delivers empirical measure of the relationship between the indicators and the constructs, as well as between the constructs, so we can determine how well the theory fits the data. PLS SEM results are reviewed and evaluated using a systematic process. The goal of the PLS SEM is maximizing the explained variance or the R-square value of the endogenous latent variables. For this reason, evaluation of the model, both measurement and structural, focus on the model predictive capability. So the most important measurement models are reliability, convergent validity, and discriminant validity. For the structural model are R-square or explained variance, the F-squared of the effect size, and the Q-squared predictive relevance. The systematic evaluation follows a two-step process, one measurement model and structural model. And measured model could consist of reflective measurement models and formative measurement models. Assessment of reflective measurement model includes internal consistency, convergent validity, and discriminant validity. On the other hand, formative measurement model consists of convergent validity, collinearity between indicators, and significance and relevance of outer weights. The first evaluation of the measurement model is internal consistency reliability. To evaluate internal consistency reliability, researchers using Cronbach alpha and composite reliability. Cronbach alpha measures the reliability of a set of indicators. The value of 0.7 is regarded acceptable at earlier phase of the research. At later, the threshold should be higher, for instance 0.8 or 0.9. Second is the composite reliability, also known as George-Koch rho, measure the reliability of a set of indicators. The threshold and interpretation is the same like Cronbach alpha. To know the number, we should running the algorithm report in a PLS SEM software. All partial regression models are estimated by the PLS SEM algorithm's iterative procedure. So select a value of at least 300 for the maximum number of iteration. Now we go to the software and run the algorithm report. So go to the Smart PLS 3, and this is the model that we have created in session 2. Then this one, go to the calculate to run the PLS SEM algorithm. Calculate PLS algorithm. Then the system will ask you, use the 300 maximum iteration and start calculation. The system will automatically give you the report. The reports include final result, quality criteria, interim result, and base data. Also, you can see the path coefficient. Just click on this, and then it will give you the path coefficient graph. To have a good understanding of the report, I suggest that you go to the export to Excel file. Just click here, export to Excel file, and then start exporting. Here, save in the folder that you like. And this is the report of Smart PLS in Excel file. As you can see, they have final result, quality criteria, interim, and base data. Now we have to find the Cronbach alpha and composite reliability. It is on the quality criteria, construct and reliability and validity. Just click here and it will give you the construct, reliability and validity. This is the Cronbach alpha numbers and this is the composite reliability. Take a look at the number. If it is greater than 0.7, it means that model or evaluation criteria for reliability has been met. The same with composite reliability. Now we have the result of internal consistency. As you can see, all the construct except the customer loyalty has value greater than 0.7. The criteria is 0, between 0 and 1, and 0.7 is mostly expected. Also the composite reliability, they all meet criteria of internal consistency. Second evaluation is about convergent validity. Convergent validity is the extent to which a measure correlates positively with alternative measure of the same construct. So to evaluate convergent validity, consider the outer loading of the indicators and the average variance extracted, or AVE. The criteria of outer loading should be greater than 0.708. The latent variables can explain at least 50% of its indicator variance. The loading 0.4, 0.5, 0.6 and 0.7 can be accepted if leads to average variance extracted that is larger than 0.5. So the AVE, comparable to the proportion of variance explained, the value ranges from 0 to 1. The AVE should exceed 0.5 to suggest adequate convergent validity. Now we are going to see the outer loadings value and the AVE value. For the outer loadings, it is under final result. Just click here and then you can see all the outer loading value should be larger than 0.708. Here all the outer loadings meet the criteria except the customer loyalty 1. It has 0.002. To see the AVE value, we need to go to the construct reliability and validity. Just click here and this is show you how the average variance extracted the value. The AVE number should be higher than 0.5. So as we can see that all the construct has the AVE value higher than 0.5. Now we have the result of convergent validity, which is the outer loading number and the AVE number. As you can see here that the criteria of outer loading should be higher than 0.708 and the criteria for AVE is higher than 0.5. So all the AVE here fulfill the convergent validity criteria. Also the outer loading except for the customer loyalty, the result 1. Now we evaluate the measure model using discriminant validity. Discriminant validity is the extent to which a construct is truly distinct from other constructs. It implies that the construct is unique. To evaluate discriminant validity, consider treating cross-loading, Forner and Lacker criterion, and the HT-MT ratio. Forner-Lacker criterion is compare the square root of the AVE values with the latent variable correlation. So first thing, we need to find the latent variable correlation and then compare to the square root of the AVE. The first go to the report of the latent variable correlation. Here the latent variable correlation will show you the value of correlation. So copy and this data and then compare to the square root of the AVE. To find the AVE number, just go to the construct reliability and validity. Click here will find the AVE numbers and then copy, and also we will calculate the square root of the AVE. This is the result of the Cornell and Walker criterion as shown in table. The square root of each construct AVE should be greater than its higher correlation with any other construct. As you can see here, the square root 0.89863 should be greater than its higher correlation, should be greater than this number, should be greater than this number, should be greater than correlation with other constructs, should be greater than this number. So also this number, the square root AVE, should be greater than any number here. The square root AVE of the customer satisfaction should be greater than correlation with other construct. Here 1 greater than 0.119. Therefore, the Cornell and Walker criterion has been met. For cross-loading criteria, cross-loading reports show that all indicator autoloading on the associate construct are greater than all of its should be greater than all of its loading on the ordered construct. To know the cross-loading value, go to the report and then under Discriminant validity, click, and it will show you the cross-loading value here. All indicators outer loading on the associate construct, so this one to this one, this should be greater than all of its loading on other construct. It should be greater than all of this number. Also for this, should be greater than this. And for customer loyalty, this one should be greater than all the numbers here. Also this one, the likability of the company should be greater than all of the number in this area. So here's the cross-loading result. As you can see that this number greater than any number in here, this number should be greater than any number here, and this number should be greater than any number in here. So the cross-loading criteria is fulfilled except for the customer loyalty number 1 here. The last is STMT, an estimate of the correlation between the construct based on the average of STMT as suggested by Hanseler. The ratio of STMT is expected lower than 0.9. To examine the STMT ratio, we test whether the STMT values are significantly different from 1. To know that, we go back to the report. The result shows that the STMT value should be lower than 0.9. Here, all the value is lower than 0.9. But we also have to test that the number lower than 0.9 at 95% confidence interval should be significantly different from 1. What we do is we go create the bootstrapping report and then evaluate whether the STMT values are significantly different from 1. To create the bootstrapping, just go to the calculate and then go to bootstrapping report and start calculating. And on the bootstrapping report under confidence interval bias corrected, that we can see here, there is no number 1 or all number is different than 1. This is the result summary for reflective measurement model. Discriminant validity including STMT confidence interval doesn't include 1. Yes, yes, and the convergent validity, the AFV and loadings all meet the criteria except on this one. Also the internal consistency, reliability, the Cronbach alpha and composite reliability